this is John Hart, and we'll be going over Module 3. Got the one assignment plus the Wiley homework. So the one assignment is the short paper 3-1 on this, what is called a scatter plot, looking at different countries and their ecological footprint on the horizontal axis and happiness on the vertical axis. So each symbol here looks like they're triangles, and we see the legend over here. Triangles, circles, diamonds, different colors, and representing different regions of the world. So we can see as the ecological footprint increases, meaning they're using more resources, as that increases, we look to this axis. What's happening to these numbers? Are they increasing also? If it was a perfect correlation, we'd see a straight line going like 45 degrees. Another way to say it, we could say it geographically, going northeast, like from Arizona to Maine, would be called a direct correlation, meaning as one axis increases, so too does the other. We don't see an exact straight line, but we see a tendency. If these numbers were getting smaller as these numbers got larger, then we would see the direction going, shall we say, southeast. That would be an indirect correlation. Another term for that is inverse. Yet another term is a negative correlation. Back here, another term is a positive correlation, or direct. But we see a tendency. And it kind of goes up and then it hangs a right. So there's a tendency. And I'll let you decide what that tendency is. And this is from my module announcement, describing what correlation is about. Got a little typo there. Correct that before I post this announcement. So mention the direction and estimate the correlation coefficient. You don't have to do any calculation. And the strongest correlation would be 1 for positive or -1 for a negative. So the minus indicates this direction, y-axis getting smaller as x gets larger. No sign on the coefficient means it's positive. So whether it's inverse or positive, it's not going to be a 1. So somewhere between 0 and 1, or 0 and -1 if you think it's inverse. So the rest of my unit announcement describing this assignment, you can check that, and you can check the course page, of course, and the rubric. So let me know the overall trend, rather than just picking out one or two and telling me about that. I want to hear what you think of the overall trend of all the data points. So even if it goes against our expectation of what we think should be happening as far as happiness and using the planet's resources, the assignment is asking you what the data is saying, not what we want it to say. And that's an important lesson in research. What's the research saying? Assuming it's a valid study and done properly, we may not like the findings, but they still are research findings, and if other studies corroborate it, then that may be the correct answer. But we still want to be open to future research that may refute what is being found today. So the directions ask for estimate of the correlation coefficient with a range of a width of no more than 0.2. For example, coefficients of 0.1 to 0.3. There's a width of 0.2. So this is pretty weak correlation here. And 0.9, 0.8, 0.9, that would be very strong. Again, 1.0 being the strongest. So you can go by just looking at the graph, as I mentioned in my announcement. But if you'd like to calculate that, you are welcome to. I give some more information on that. I have a video on how to do that, getting the raw data and doing that in Excel. So again, the range of the coefficients goes from -1 to +1. So if I see numbers outside that, that is going to be incorrect. And again, give me the direction, whether it's direct or indirect. And what could affect the size of the correlation? Well, you'll find in your readings that outliers can change that. Like this is kind of outside the general pattern, and so is this. That can pull the coefficient one way or the other, depending on the location of the outlier. Pull it toward more positive coefficient, like from 0.7 to 0.8, or it could pull it to more negative, -5 instead of minus 0.5 instead of minus 0.4. Here's some examples of scatter plots and correlation coefficients. Denoted as R is the symbol, the letter for correlation coefficient. So correlation coefficient, also known as correlation statistic. So here we see going northeast, so that's positive. Here it's going southeast, that's negative. We see the minus sign on that. Negative linear correlation. Correlation looks at linear relationships. So if we have nonlinear, like going like this, then that would be